Hi everybody, this is Mr. Nolan, and what I'd like to do with you in this video is talk about glaciers. So we know a lot about how glaciers behave. What we're maybe not really quite sure on yet is how do we look at the landforms made by glaciers and figure out what the glacier was doing when those landforms were created. So I've basically got three goals for us in this video. After watching this video, you should be able to identify glacial landforms just based on how they're built. What is this thing called? So if you see a picture of a landform, you should be able to identify that's what that's called. We want to be able to infer what the glacier was doing based on those glacial landforms. So if you identify a drumlin, you want to be able to say, well, what was happening here when that structure was formed? And then lastly, we want to be able to identify some of the processes by which glacial landforms are made. So I'm talking about things like erosion and deposition. At least you should be able to identify those kinds of processes going on. So let me kind of identify some of the key vocabulary for you that we're going to be learning about. These are in no particular order. We're going to start with drumlins, eskers, end moraines, striations, glacial striations, and these last ones are highlighted in blue because these have to do with ancient lakes that are glacial lakes. They're called lacustrine deposits and remnant shorelines. And so these are kind of in a special category because they're not really directly caused by glaciers, they're really caused by the lakes that are left from the meltwater of those glaciers. Okay? So drumlins, eskers, end moraines, striations, and then these lacustrine features. And by the way, if I go really quick in this video, use that those pause and play buttons. That way you can kind of maybe go back and try to re-listen to something that I've just said. So one thing that we want to know is what this stuff is. This is called glacial till. Till might be kind of an unusual term. You might not be really familiar with it. All that it really means is that it's a blob of mixed sediments. So it's basically just a lot of gravel. So you see rocks, there's some sand and silt. So this is some glacial till that has been formed just by the glacier shoving sediments around. They're unsorted, they're not in any particular arrangement. They're just a big blob of gravel. That's pretty much what glacial till is, and it's caused by that sort of bulldozer effect of the glacier moving around. And so this is a really nice sort of diagram of what a glacier is doing. As the glacier is moving around, it's creating all these features, and so we're going to be looking at some of these features in a bit more detail. So let's go ahead and look at drumlins. So drumlins are usually, you're not just going to find one drumlin by itself. You're going to find drumlins in fields. And this particular photograph is really good because it was taken in the winter time, and you can really see the relief. You can see that there are these stretched out hills. So I want to show you where some of these are. Some of the best drumlin fields are in Wisconsin. There's a few in Michigan, and so I want to show you where we're going to find some of these. Okay, so one of the areas where we're going to find a lot of drumlins is in the UP in certain areas. And so I kind of want to show you what these look like. I went to the UP, so we can see we're kind of down here. This is the Lake Michigan over here. And so what this area is, you can kind of tell from a long way up. You see these streaky, almost these, you can tell that things are sort of stretched out in a certain streaky sort of direction. And so if I kind of zoom in here a little bit, and if we look at this in 3D, what we can tell is that there's these raised areas, these hills, these stretched out hills. Do you see how there's sort of these elongated, almost teardropped shaped sort of hills? You can see them. And one of the things that's, one of the ways that in these images, the reason they look so easy to identify is because they're vegetated differently. Different plants live up high on the hill as opposed to down low in the hill because of different amounts of water. That's kind of an extra detail, but if you look at them, there's these long stretched out hills, and they're actually really easy to spot in certain places. If we head up to Wisconsin or other areas in places that were glaciated, we also spot them really pretty easily. They're easy to spot. So here I'm moving over to Wisconsin, and we can tell in some of these areas where they're sort of forested and a little bit higher up, these are sort of hard to spot. But like this is a big drumlin. This little forest right here, this forested area, this isn't a high spot. It's a hill. And you can look, again, as I look down on the satellite view, you see all these stretched out hills. These aren't as easy to spot as the ones I just showed you. And there's also some more in the lower peninsula of Michigan. This is in the Traverse City area. And again, from a distance, it's actually really easy to spot them, these stretched out mounds. And if I zoom in, some of them are even easier to see. If you kind of see some of these high forested areas, these are high areas. These are drumlins, and so they're these stretched out hills. And what drumlins, we're not actually really sure exactly how they form. They form by some process of deposition and erosion. We're not exactly certain. But the important thing about drumlins is that they point in the same direction that the glacier was moving. So if I kind of look at this drumlin field in Michigan, we can tell the glacier was kind of moving south and a little bit east. Do you see how they're kind of stretched in that direction? So that was actually the direction that the glacier was moving, and this part of Michigan is sort of in a southeast direction. Same thing over here. Actually, these are in a different direction, and these ones in the UP, these are kind of more like southwest. See how those are stretched sort of in that direction? So we can use drumlins to figure out what direction that glacier was moving. They go parallel with the glacier. If we jump over to eskers, eskers are these ribbons of sediment that are left by rivers that are actually flowing under the glacier, and they point in the same direction that the glacier is moving also, just like drumlins. There's a couple in Michigan. This one I found, which is in the Alpena area, which is interesting, is that it's actually been mined for gravel. You see how it's kind of this winding shape? It's a little bit hard to really see it on the relief, but what's interesting is that enterprising entrepreneurs in this area are actually starting to mine it for gravel. And so this esker is being mined for gravel. I found a couple of others in Michigan. This one's a little bit hard to spot, but if you can maybe kind of see it in your screen, there's this kind of raised area right here, this sort of ridge. This is an esker that has actually been vegetated, that's covered in forest. It's really hard to see now. Let me show you some ones that are actually easier to spot. So this is in Iceland, and in this glacier in northern Iceland, see these kind of they almost look like rivers, these sort of like branched, sort of tree-like shapes. These are eskers from this ancient, or actually these are recent eskers that are formed from this glacier. Here's some that are nearby, here's some more. We can see all these eskers all over the place. Because this was once covered by a glacier, and the water that was sort of pumping down under the glacier formed these deposits, these sediment deposits. The way by which glaciers are formed is sort of complicated, but basically they're just these ribbons of sediment that are left by ancient or past rivers that used to be under the glacier. They're not there anymore. In fact, the glacier isn't even here anymore, but those piles of sediment are, and eskers move parallel with the glacier, so they move in the same direction that the glacier was moving. Let's look at moraines. Let's look at end moraines in particular. I found an image here. This is actually in Baffin Island, Canada, and if you look here, this is a glacier, sort of the terminus of a glacier, sort of pouring down from this mountain. And if you look really carefully, you'll notice this kind of ridge, this tongue-shaped ridge that's sort of been shoved by the past extent of the glacier, which is actually pushing all that sediment forward, all that till. So if you look really closely, can you spot that end moraine? It's right here. Right, I've got it highlighted in this dashed line. This is where the maximum extent of that glacier pushed, and it shoved all that material. I can show you a few more on Google Earth here. This one is also in Iceland, actually, and this one's actually very easy to spot. So this is a glacier over here. There's its terminus. And we can tell that, at least recently, this is the maximum extent of this glacier right here. It shoved all the way out, and it stopped right there, and then it started to retreat again. And so here's our big outwash plain, right? This whole area is an outwash plain, and this is how far that glacier pushed, and it shoved all that glacial till forward in this sort of this ridge. And so that's what we call the terminal moraine. It is the moraine that was caused by the terminus of that glacier, the maximum extent that it went. And so here's the terminal moraine that I already showed you. Lastly, lacustrine and ancient shorelines. So lacustrine deposits are sediments that are formed when you have an ancient lake, a glacial lake, and that lake gets filled with clay and sediments that are coming off of the glacier, and you end up with what we call lacustrine deposits. Lacustrine just means it's formed by an ancient lake. And so I'm going to show you some of those, what those kind of look like. So this is a very muddy, sort of clay-filled lake, a few sets of lakes that we can tell there's a glacier over here. You can see its terminal moraine right there. And so this is a big, muddy, nasty lake. that's in several lakes that are being formed as that ice melts. And so these are going to give us someday lacustrine deposits. If we jump over here, and if we look at this GeoWeb face, if you remember this this delightful app that we used, we can actually very easily see miles and miles of lacustrine deposits in Michigan, in the Saginaw area and the Detroit area. I'll show you kind of a composite image that I put together here. So this is the state of Michigan. We've seen these quaternary deposits before. And if you look really closely at these blue ones, you can see there's a big blob of lacustrine deposits, and there's a big blob of lacustrine deposits. And one of the incredible things about this is that it means that Lake Huron and Lake Erie down here used to actually be all the way up on land, like way up there. So they used to be much, much higher. And so this lacustrine deposit has been left by ancient Lake Huron. We didn't call it, it didn't used to be called Lake Huron, now it is. Like these lakes have all different names. There's Lake Algonquin, and there's there's all these different lakes. But this is where they actually used to be at one point way in the past. When those glaciers had melted, they left all this meltwater, and the water was still draining away. And so this is all clay, right? So and there's some gravel here. So if you were to step anywhere inside this dotted line, you'd find a whole lot of clay and gravel. And if I kind of zoom in here to where I grew up, sort of my old stomping grounds, this big area right here, this is roughly where Richmond is, and you can see all that lacustrine clay and silt, all this blue stuff. This is all clay. And so when I went in, to play in the backyard or to work in the garden or whatever I was doing, if I dug a hole or something, it was always clay, very hard, soaked up a lot of water. And that's because that an ancient lake used to be there. And so that's why we find so much clay in certain areas of Michigan. There used to be ancient lakes there. And lastly, actually the last thing I want to point out, I'm going a little out of order here, but glacial striations. So a striation just means like a scratch or groove. And so this, to kind of put this into scale, I found a photograph with a person in it. You can kind of see these scratches. You see these scratches on the bedrock? Striations happen in rock. They don't happen in sediment. They happen in rock. This is a really good image. I'll make this, bold this so it's a little easier to see. This is a really excellent image that I found where this bedrock, if you look closely, like this is actually way up on a mountain, and you can see some trees down there. Here's a little shrub for scale. The glacier that formed these striations rode right over that mountain and just scratched all these grooves into the bedrock. And so glacial striations, you're only going to find these in areas where there's basically naked bedrock. If you've got sediment, you're going to get things like you're going to get things like drumlins and eskers. You'll find moraines. But if you actually have bedrock, that's when you get striations. And the striations also move in the same direction that that the glacier did. And also, before I forget, I want to point out, if we look really closely at end moraines, they don't point in the same direction that the glacier was moving, at least on the end. They're actually perpendicular. And so this end moraine way down here, it's actually pointing, it's making sort of a 90-degree angle of where the glacier was flowing at that moment. So end moraines show us the end of where the glacier was, and so the glacier was actually moving at a 90-degree angle compared to those end moraines. So just to kind of recap everything, you probably want to take maybe a little screen grab here because these are some very important terms and definitions. Drumlins are mounds, hills of glacial till, and they're parallel with the flow of the glacier. They point in the same direction. Eskers are these winding ribbons of river sediment. They are parallel with the flow of the glacier also, just like drumlins. Endomoraines are ridges of glacial till. They're shoved up by the glacier terminus, the end of the glacier. They are perpendicular with the flow of the glacier. They're not parallel like the others. They're perpendicular. Striations are scratches or grooves that are carved in the solid rock by the underside of the glacier. They are also parallel with the flow of the glacier. And lastly, these lake features. So lacustrine deposits, these are mostly clay, but there are other sediments too. Left by deposition in ancient glacial lakes. This shows where ancient lakes used to be. And then remnant shorelines. We didn't really talk too much about those, but basically a remnant shoreline is where the edge of a lake used to be. So these the dotted lines up here, these are ancient shorelines. This is where Lake Huron and Lake Erie used to be before they drained away. So I hope that this video was helpful and instructive in helping you to identify glacial landforms and infer what the glacier was doing there.